So this is a tripod stand. First what we have to do, first we have to unlock all the attachments. After that we have to move it vertically upward direction, make it straight. After making it straight, by adjusting suitable height, we have to make all the attachments. After that we have to expand these legs, 3 legs, in such a way that this upper plate of this tripod stand must be horizontal. It must be horizontal. Okay, this is a temporary adjustment. So this horizontal plate must be horizontal. It must be parallel to the ground surface. Okay, now next. Now what we have to do, we have to set the total station on this tripod stand by fixing this screw. You can see here, by rotating it in clockwise manner. Now what we have to do, we have to set the batteries in the given slot. There are 2 batteries, so 2 batteries we have to put in this slot. You can see here, this is the slot. This battery we have to insert in this manner, and after inserting we have to lock it. Now second battery also we have to put in second slot, and this is the second battery, and we have to insert it in this slot and we have to lock it. Now we have to remove this prism. This is the prism which we will use for total station surveying for bisection. So we have to fix this prism in this prism rod. The marking is shown here. You can see here, up to this marking, the black color line placed in horizontal manner. We have to place the prism up to this and fix it with the help of clamping screw. This prism must be completely horizontal. For that, the circular bubble tube is given. The bubble, while what the prism man will do, he will hold it in vertical manner by observing this bubble is at center or not. First we have to do leveling. First you can see this marking. Up to this you have to take all the foot screws. It is a center position. Up to this marking you can see here, you can rotate the foot screw in clockwise or anti-clockwise manner.
So we have to basically level this equipment by using this
three foot screws. Yes. First see that this plate of tripod stand is horizontal or not, whether it is parallel to the surface of the ground or not. After that, what we have to do, we have to on this particular instrument by pressing the green key. First I will give basic information about this instrument. This instrument is called as total station. So the manufacturing company of this instrument is Trimble M3. So this instrument, you can see here, it is a telescope. This is telescope. It is having auto locking system. So this is your eye vane. From this side you can see this is object vane. So this is a horizontal slow motion screw. This is vertical slow motion screw. This is a clear image screw. So this is a digital display you can see here, and here there are some keys which we required for operating. Okay, now these are the foot screws, and this is the stick which we will use to operate this particular instrument. So you can see
basically we have to give input from this
yes
keys,
from
through
these
this.
keys.
Okay.
So while typing some information, we have to press Control 7 so that the keyboard will appear. You can see here. So I will show afterwards. So now what we have to do, the Trimble M3 with prism it is having 1 kilometer range, and without prism this instrument is having 4 kilometer range. The cost of this instrument is 4 lakh. It is having 1 second accuracy, and without prism mode, that is direct mode, it is having 5 second accuracy. Okay, now after switching on this instrument, what we have to do, you can see the display is occur. It is having one longitudinal bubble tube, one transfer bubble tube, and one circular bubble tube. Now what we have to do, first you can see here I will explain one thumb rule regarding this, how to set this bubble at center. First you can see here the bubble of circular bubble tube is at towards this direction, that is towards this direction. So in first quadrant, what we have to do, opposite to this foot bubble, which foot screw is there, you can see this is the foot screw. So I will rotate this foot screw so that I will try to make this bubble at center. Now you can see the movement of bubble is towards left side. Now I will rotate opposite foot screw. Now again it is towards right. I will rotate left side foot screw. Now it is moving towards left. I will rotate right side foot screw. Now you can see here the bubble is approximately at the center. So you can see the sighting, that is 0 degree 0 minute 27 second. So 20 second it is having some difference. Now you can see the bubble is approximately at the center. Now what we have to do, we have to disable the compensator and we have to accept it. Now, okay, while starting the topographic survey, what we have to do, first we have to go in the file menu, we have to select new job, we have to give the name to this particular job. For appearing the letters on the screen, what we have to do, Control 7, we have to press Control 7. So I will give name to this job, that is civil. Again I will press Control 7. The keyboard will disappear. So these properties are set by the manufacturer. These are the by default settings. I will press enter, accept. Yes, okay. Now what we have to do, again go in the survey, that is what we have to do first, that is station setup. So station setup. Now this is your instrument station. First we have to set this station. Okay, so instrument point name we have to give, I will give 1 number point. Again Control 7, 1 number point. Code whatever may be, this is instrument station, I will give code as a instrument station. So instrument station. Now instrument height, we have to measure the instrument height. So we have to measure the vertical height of this instrument up to this mark. You can see here, up to this mark we have to measure the vertical height of the instrument. So after measuring the vertical height, the height of the instrument is 1.5 meter. We have to enter here, that is 1.5 meter. So again control 7. So default instrument coordinates, the coordinates of this instrument, that is x coordinate, easting is 1000, y that is northing is 1000, and z coordinate, that is reduced level up to this height from mean sea level I have considered, that is 100 meter. Okay, so again we have to enter here, enter and accept. Now backside point name. What is backside point name? Whichever survey we are conducting, first we have to locate the north. With reference to north, we have to conduct that particular survey. Okay, so backside point name is, that is north direction. I will mention here backside point name, that is second point, control 7, that is 7 point, code I will mention here north direction, north. Backside height. Now we have to measure the prism height and we have to enter at the backside height. Okay, here the backside height, it is 1.5 meter. So this is prism height. Now what we have to do for north direction, from this instrument, from this telescope, we have to bisect this prism. Okay, this prism must be towards north direction.
Here we have to select for bisecting this one. In this one, target 1 and target DR. That means target 1 is with prism and target DR is without prism. So we are using prism, so we have to select target 1.
Now first what we have to do, first we have to bisect that prism accurately by using this particular eye vein. After bisecting it perfectly, what we have to do, we have to, now you can see here backside point name, it is second point, the reference direction is north direction, backside height, that is height of the prism is 1.5 meter, and assumed means the angle which we are bisecting is 0 degree 0 minute 0 second. We have to choose the method, that is angle and distance. Now after bisecting perfectly, I will press on measure option. Now you can see here the instrument point name is 1, instrument height is 1.5, backside point name is 2, backside height is 1.5, assumed is 0 degree 0 minute 0 second. Now I will enter here. You can see here horizontal angle which the instrument have taken is 0 degree 0 minute 0 second. Now and the vertical angle, that is it is parallel to the horizontal axis of the telescope. It is 90 degree 0 minute and 53 second. Some manual error have occurred. So you can see here I will press store. Now the instrument setup is completed. I will show some signals which the instrument operator will give to the prism man. Okay, now first you can see here the rod of prism man is tilted towards left. We have to give signal that it is tilted towards left. We have to make it vertical. So it is tilted towards left. We have to make it vertical. Okay, now you can see here the prism rod, it is tilted towards right. We have to make it straight. You can see here the prism man has hold the strap, that is the prism in towards right, we have to make it straight. Now next is this movement. So that is, if he is showing this signal, that means you have to, the prism one have to shift his position from one place to another. You can see here that he is showing this particular signal, that prism one have to relocate his position and move towards left direction. Now he will show that is right hand signal, that is it is moving up and down. It is the symbol is showing that the prism one have to move from this position towards right position. That is, he have to relocate his position. If he is standing at correct position, what we have to do? He will show this signal. If it is he is standing on correct position, we have to show this particular signal. That is, instrument operator, that is total station operator, have to show this signal to the second point, prism, that is north direction. So after bisecting the north direction, our instrument station will be complete. Now what we have to do? We have to bisect second point, that is north direction. After bisecting north direction, the instrument setup will be completed. Now after completing the instrument setup, what we have to do? We have to go in the survey, go in the measure topo tab. Now we have to give the base point name, that is control 7. We have to give base point name, that is point number 3. North direction, we have to select here method, that is angle and distance. So target height, that is the height of that particular prism, is 1.5 meter, that we have saved here. Now we have to bisect that third point and we have to click on measure. Now I will bisect the third object. I have bisected point number 3. Now I will press on measure option. Here is measure option. I will click on measure option. So you can see here one particular window will appear. It will give us the horizontal angle, vertical angle, slope distance, as well as it will give us X is easting, Y is northing, that is north coordinate, and Z is elevation, that is from a reference benchmark what is the height of that particular object. Okay, so I will click here store. Now we have to bisect point number 4. So I will pass one message to that staffman, that prismman, to shift his position from one location to other location. location, that is point number 4. Now again I will repeat the procedure. I will bisect object 4, that is point 4, and I will click on measure option.
Sir.
Now you can see here I will bisect that is point number 4, and I will click here enter. You can see here by entering I will press on measure option. So after clicking on measure option, you can see here one window will appear. It will give us that is east coordinate for that new location point number 4, that is y coordinate, it is north, and z coordinate, that is elevation. So I will again store the coordinates in the system store. Now I will give one signal to the prism one, that is shift towards new location. Now we have to bisect point number 5, that is fifth object. You have to bisect the point or the prism at any point. After bisecting the object, perfectly bisecting point number 5, we have to click on measure option. Now one new window will appear. It will give us the coordinates for fifth point, that is x coordinate, that is easting is 1003.2 meter, y coordinate, that is north direction 1032.9 meter, and z coordinate, that is reduced level, that is elevation from considered benchmark, that is 100 meter, 100.1 meter. So we have to store it. Now we have bisected this 3 point. Now if I have to find out the area of this particular bisected objects, so you have to go in the map. You can see here, go in the map. By zoom in, you can see here first point, that was instrument station. Second point, it was north direction. Third point, fourth point, and fifth point. These are the points which we have bisected. Now I have to find out the area. What I will do, I will select 1, 2, 3, 4 and 5 point, and I will long press on this window. You can see after long pressing, you can click on the option, that is compute plus subdivide area. So you can see here the window which is appeared, it gives us perimeter of this particular survey, that is 114.75 meter, and area is 0.208 acres. So I will store it. So our area calculation is now completed. Now for coming outside from this particular file, what we have to do, we have to press escape, exit, shut down digital fieldbook, yes. So long press here, shut down digital fieldbook parenthesis. Now we have to long press on this green key. You can see here option. Now one option is there, that is shut down. Shut down. Do you want to shut down the device? Yes. So the survey is. Now this was the first part, that is area calculation. In second part, we will see the different functions which are used in total station survey. First is coordinate stakeout. Second is remote object, that is remote distance and remote elevation. So we will see this part in second part. Thank you. I express my gratitude to all the team members, those who help for making such informative total station video. First of all, I would thank to Dr. V.N. Kante, who advised us for making this particular video. Next for Rahul, Pratik, Rohit and my assistant Pawan Jadhav. Thank you. Please like, share and subscribe for this video. Thank you.